Hello, everybody. Okay, people coming in. Let's wait 2 more minutes.
Good morning.
Good morning.
Hey, Hendrik, can you refresh that page? I just added a link to HOL's. Let me see if it appears. Yes, it appears. Okay, thank you.
Okay, now all the people coming in. That's great. So let me already start with the introduction. So welcome everybody to the Hiero TSC call. Like any call we do in the Hiero project, this is a public call, which means everybody is invited to join us here in this call and to bring in thoughts or discuss topics with us. You can find the invites to those calls in our public calendar. In the end, it's just a Zoom link. And if you go to our public calendar, where you can find the link to on our webpage, in GitHub, or in the meeting notes, you will see that we have multiple events or meetings every week. Like directly after this call is the Hiro marketing call, and I came from the Hiro community call, which is just before this one. And if you miss a call, you can always click to previous, or let's get maybe first go to the current one, and here you find the link to join the call, the Zoom link. And if you miss one of those calls, you can just go to a previous call, and here you will find a recording of the meeting. And since all that is happen in the public, and this is not a webinar where you are not allowed to speak. You can, if you want, unmute yourself, ask questions. Please raise your hand first here in Zoom before doing so. But since all of that is possible, we have some basic rules we want to follow, which is the antitrust policy of the Linux Foundation and the code of conduct of the Linux Foundation. And with that, please, like, bring in any topics you have in mind, join our discussions, but do it in a friendly way. Good. And with that, let's come to the agenda of today. So last week, we had a quite interesting TSC call, since we didn't really made it to the hip section, which is because we had so many of other updates, some coming from the community, some general. We have Angelina here in the call, who gave an overview of the different website designs, where the voting is still open, and you can still vote on the website designs, and we had a lot of updates and coming events from the community. And if you look at the agenda for today, you see something similar, and that is quite interesting. That is something I really seeing coming up this year more and more. That well, in the past we talked a lot about the hips and took care about that. We're getting more and more updates and events coming from the community and individual members, um, so that we at least today, really jump very fast through the section so that we have enough time for the hips today, which from my point of view is a very positive direction and thing that happens because this shows that more and more is happening in the Hiero community and ecosystem. And with that, before I go through the, what is it, 5 points, oh no, even 6 points I have here on the list, anybody of you here in the meeting has any updates or events you would like to share? Okay, good. So let's have a look at the list. So we have some meetups coming up the next weeks. We have from DSR a meetup about Hiroheka and how to do decentralized identity based
Uh,
on
just
Hiro.
um, just a little that one happened last week.
Oh,
I posted the
oh, you're
recording.
right. Oh, for me it was still in the future. Oh, that's good. So I can watch the recording. That's good to know. Do you know if the recording is already online?
Yes, I posted it in the chat, but I can update the link there
Perfect.
so that
Oh
it
yeah,
access to
that's
the
great.
recording.
Yeah, yeah, because I want you to watch that. Then we have a meetup later today, which is enabling to, like build applications on top of Hiro. So this will be about how to use the SDKs, how to set up a network by using Solo, and so on. And I will go through those topics and give an introduction on Hiro. So maybe not for the people here in the call, but if you have colleagues or friends who are new to the community, I think that would be a good introduction to it. And then we have Michael who gives a presentation in a virtual meetup too. Michael, before I tell something wrong, do you want to say 2 sentences about it?
Yeah. So this is going to be on June 2nd. We're going to be talking about the two specifications that GoDaddy has contributed to the Hiero consensus specifications repo. So it's the amendment to HCS 14 and HCS 27 for publishing their ANS Merkle roots. So there's actually two posts already we published this morning that cover this meetup, and I believe later today GoDaddy will also be publishing some content and cross promoting it. So we should get a pretty sizable audience to this one. If anyone wants to participate or help us promote, we definitely appreciate that.
Good. Thank you. So, and then next to those three meetups, we have some news in the Hiro blog. One is really nice because Hiro was part of the first hackathon. So it was part of an hackathon run by Hedera, which was the Hedera Apex hackathon, but there was a bounty for Hiro. And if you're interested in the winners, there have been 3 projects that did like being the winners of that bounty. And I can tell you because I did the review together with Sophie, there have been a lot of very good projects, and I'm really happy that first and second place, even if that wasn't not a must or gave any bonus points, 2 of the projects are already part of Hiro Hackers. So we even got them into the Hiro ecosystem. And I hope to get the same with the other ones too, where I'm currently working on. And then, since today, we have a blog post about some community analytics online, which has a very nice chart, which is this one, that shows the community growth or the like growth of maintainers, committers, and triage members over the last years of Hiero. And I think everybody sees that this is a really nice curve going up and up and up, and especially showing that the committers are growing and growing over the time, which is really nice. But even like maintainers and committers are growing, but it's not only those people who work on it. There are a lot of more people who did contributions to Hiero. And the other thing that is quite nice, end of last year, we started, next to having good first issues, having beginner, intermediate, and advanced issues, to create a kind of flow, or path that contributors can take to grow. And for those, as you can see, a lot of additional issues has been created, especially in this year, early this year. And this is really a nice success too, where I would say a lot of those new contributors are coming from. And the last thing here is, I said it already last week. This is just a reminder. So I plan to host an agentic AI working group in LFDT. And if you are interested in it, or know somebody who should be part of it, just ping me on that topic. Yeah, those are all the updates. Any questions on one of them? I've seen there are several messages in the chat. Let me have a look at it. Oh, that is Michael. Yeah, okay, that is about your event. Oh, about the charts. Yeah, yeah, up and to the right. Yeah, that's how I see it too, which is really, really nice. Good. So, with no other comments or questions, we can move forward to the hip section. And Mark, should I just stop sharing and give it to you?
Either way, yeah, you could just pop that. Oh, okay. Yeah, I could do it in a second. Okay. Okay, I think you had 48 as the first one. So we did introduce these hips very quickly and quite a few weeks ago. So I'll just go ahead and provide a summary description, and then please feel free to ask any questions or concerns you may have. So this HIP is using the existing communication ports and channels set up to create an event broadcast method. This is in addition and will continue to run alongside our gossip protocol, but this is more of a enhancement to the gossip protocol, where nodes will first send out new events through this broadcast, and then any links or any nodes that didn't get this broadcast will eventually get that event through the gossip protocol. So this is not replacing gossip, first of all. And additionally, this is not requiring additional ports, firewall configurations, or even configurations on the configuration changes on the node itself. So this is an added broadcast layer that is used to reduce the gossip traffic. And what this does is it adds efficiency to the network. Events get shared more quickly. Consensus time is reduced, and the overall performance from a C2C, or when somebody submits a transaction till the time it comes to consensus, is reduced by this. So just a very nice add-on feature. Doesn't require or break any compatibility, require extra configuration. It's just built on top of Gossip to increase efficiency and reduce latency. Hopefully that makes sense. It's Monday on a long weekend here for us. But any questions or concerns? All right. Would we like to vote on this one, Hendrik, or do you want to wait till
Oh,
after I
let
present?
me just check if new people came because we didn't had quorum when I looked at it some like before you started. 1, 2, 3, 4, 5. Okay, Georgie is here. So we have 5, which means yeah, we could vote on it. So we don't need to do the and Milan too. Sorry. Yeah, we can vote on it. Don't need an asynchronous vote. That's great. Um, so any questions on it? Or is anybody not able to vote, need more time on that? Okay. So let's do a voting on that hip. And I start with Michael Cantor,
I vote yes.
Richard,
Yes.
Stoyan,
Yes.
Georgie,
Yes.
Migan,
Yes for me.
and I do yes too. Yeah, that's it. 6 yes on it. Voting passed. Congratulations.
All right.
Um,
Thank you.
will you directly come to the, oh, you already have opened the other one. That's good. Okay. Perfect.
Yeah, no problem. All right. So 1446, multiple other parents. So for those who know the consensus algorithm, the hashgraph consensus algorithm, when an event is created, so events are messages that contain transactions that need to come to consensus. And this is how events are how nodes share transactions with each other. And so when a new event message is created, it is tied or anchored to multiple nodes. Today, it's the originating node creating the event, and then it finds one other node in the network to associate this event to. So we call those nodes parents. So the parents of the event is first the originating node, we call that the self parent. And then one other node, we ask, hey, can you think of it almost like co-sponsoring this event? So that is called the other parent. And what this allows is really this association is used for all the nodes to reconstruct the structure of the hash graph, but then it also helps seed the gossiping of these events because the self parent will start gossiping to other nodes, and the other parent will start gossiping this information to nodes. And so think of this as kind of the roots of the event and the start of it being gossiped across the network. So what this HIP is doing is saying, okay, we have one other parent, but what if we added multiple other parents? And what this ends up doing is first you have a self, and then the first other, and then multiple other parents. So the event is when it's initially brought to the network, it now has multiple, think of it as sponsors again of this event. And so now, rather than just two parents starting to gossip out this event to the network, Now there's multiple, and this is a configurable. There is a new configuration item where you configure this somewhere. Here we go. So you could configure, you could have 2, you could have 3 other parents. This is purely configurable. The default is the current, which is just 1 other parent. But because of this, when it's seeded, it makes things again much faster with regards to when a transaction is first submitted to the network to when it comes to consensus, and it allows it to come to consensus faster, which means there's less messages being gossiped, and then also it makes the hash graph structure itself denser, so it reduces it can reduce the memory of the long-term network along with that latency efficiency. So this is a configurable item. It's backwards compatible. Again, this is just an extra efficiency layer that really doesn't interrupt any existing functionality, and it makes us faster and more efficient. Any questions on that one? Okay.
I
Sorry.
see.
Oh, yeah, please.
Yeah, there's a question in the hip from Michael Kenter.
Yeah, sorry, I was multitasking. For hips like this, I always wonder if there's like a graph or diagram that we can follow. I personally was getting a little bit lost, especially with things like this, which have like a tree structure architecture. Graphs help a lot.
Yeah, that's a good point. I can come up with a graphic that would help. There's none in the hip, but yeah, I could write something up and present it next time if you want, Michael. You need that before you feel comfortable voting.
Yeah, I mean, we can also like if we can distribute into that TSC Slack channel too, and we could just do it async, then do like an async vote or something like that, or maybe when the hip vote is set up on GitHub. I definitely don't want to mess with the process and slow you guys down, but I would love to just understand fully.
Yeah, no, I get that. No problem. Are there other questions? I could quickly clod something up too, probably here.
No question, but yeah, for me, a graphic would help too here.
Okay.
I think that is.
So how would you like to proceed, Hendrik?
So Mark, if it's fine to you, we wait to get the graphic and then do an asynchronous vote, as Michael Cantor suggested. Would that work for you?
Sure. Yeah, no problem.
Because I think then it would be the easiest way. I mean, I would be fine to vote today, but if somebody has such a request and we can handle that, I think it would be best to do it as that in this case. So yeah, just send it to me, Mark, and I can forward it to the TSC channel and create an asynchronous vote then forward.
Okay.
Maybe.
Okay. Yeah, we could do that. Is the Slack channel that's a leads channel, or is that what you're referring to?
Yeah, just send it to me on Slack, because we have like the TSC has a private channel and I can forward it. I mean, best would be if it's part of the pull request, right? So yeah, don't make sense to send it to me. Put it, yeah. I assume that is what Diane wanted to say, right? Put it in.
Absolutely.
Yeah. Forget what I said. That don't make sense. So it would be great if we could add it to the hip as like public content, and when it's there, please ping me so that I create the asynchronous vote on it.
So I
Okay.
had
one more small question, and maybe the diagram is going to clear that up too, is, and there's a pretty diagram, thank you, that
There we go.
you're talking about getting more efficiency, so hopefully making the network more efficiency by having multiple other parents. But that seems to be adding more computing at the same time. Is there a way how are you quantifying it being more efficient than the one parent or the two parent rule?
How is it more computing? I don't
Well, if there's
fully
more
understand
other,
it.
this is me trying to suss out this design.
Oh, okay.
The if there are more other parents, each time there's a new or another other parent, that's a compute event. Um, Without those other parents, there was only two, and from what my logic says, one compute parent. But here you're adding multiple compute parents, and what I thought I heard you say is that just makes the less burden on the gossip mechanism. So is that where the efficiency is coming from, the
Yeah,
less burden?
correct. Yeah, and it's not a computation parent. I don't want you to think that these other nodes are, doing serious compute. It's just the message is tied to that other parent or multiple other parents in the graph. Maybe let me walk through this diagram real quick. I think this may help.
Oh,
I
Um,
see Richard has
so,
hands up. Oh, yeah, okay, continue.
oh yeah, please, Richard, you probably do a better job than I on this.
I have a slide deck that I've used in the past that I thought I might share and just kind of give a quick overview. The full thing takes, I mean, to really understand the algorithm and how everything fits together, it's a long, we should do a lecture series. It's quite long, but I can at least give a flavor for what it is that you're trying to do in the hash graph. So fundamentally in the hash graph, the fundamental problem that you're trying to solve for is branching. Branching is when one node is being dishonest relative to other nodes. And this is an example here of some type of a hash graph that's broken, in that Bob here is a liar and has created two different events. And he shared some of those events with one person and some with another person. And that's the fundamental problem that you're trying to solve for. And so there's this thing in the algorithms called strongly seeing. And the way that it works is that you have some event, and that event needs to be able to see this other event Y. So X is trying to see Y, but it has to see it through a whole pile of other events that can also see Y. So X is saying, well, Alice, I'm Alice, and Alice has got some event in this set that can see Y. And Bob has an event that can see Y. And Carol has an event that can see Y. And Dave has an event that can see Y. And even though Emily over here doesn't have an event that can see Y, it's okay because I have enough of them. And what this is proving is that these individual nodes absolutely have all seen Y because we have cryptographic hashes tying everything together. So we know that, this, from the perspective of this event, it can see Y through over 2/3 of all the different members in our network. And that's and this is the fundamental theorem here, is that if greater than 2/3 of the parties are honest, there exist solutions to the hash graph. So in a more, like, if you were to look at the full graph, you have some event, and can I see why? Well, through here's one path that I can see it going through one of Carol's events, because this event has another parent here, this event has another parent here, this event has a self parent here, this event had an other parent here, and therefore X can see Y through these parent links. And if you go through, you have to do this for every single. Basically, you're going to come if you are doing the processing for this event, you're going to, for Alice, for Bob, for Carol, for Dave, and for Emily, you're going to try to see if there's a path that leads you back to to Y. So this is the way that the algorithm works today. What multiple other parents does for us is instead of having, like if you look at this, because each event only has two parents, a self parent and one other parent, you have to build the graph up pretty high before X can see Y. Because if this was our X guy, he obviously can see Y, but only directly and not through anybody else. So then you have to have another event created who now has a chance to see Y this way and this way. But that's still only 2 of 5 members. So you need to have another event to even have a chance of seeing Bob with 3 of 5. And you have to have another event to even have a chance of this event seeing it through 4 or 5. So it's like you have to create quite a few events and you have to do quite a lot of processing in order to find why. On the other hand, imagine if this event right here, or maybe this event right here, was able to have multiple other parents. It might have an arrow pointing here and here and here and here, and they all are pointing to Y. So instead of having to go 4 levels up, I could just go 2 levels up and I could still see Y. And if I can do that, then it means that I can divide. This algorithm is used for dividing events into rounds, and rounds are the chunk of work that we do that then feeds into a block. Some whole number of rounds become a block. So if we can do fewer events, then it means that each event is we can basically make the rounds come faster. And what that means is that your end, like the time to consensus right now, I think on mainnet is like 2.3 seconds or something like that. And you can bring that time down because it just doesn't take as many events that you have to globally distribute in order to produce a round. You can do it much smaller. And in internal tests, this isn't going to happen on mainnet, but you remember one of the projects we talked about last week, right? The idea was like, how can we get our latencies down to the speed of light, project light speed? And we have the consensus system with multiple other parents enabled. We are seeing on a 4-node network where all the computers are right next to each other, consensus times at 2.5 milliseconds. You heard that right, 2.5 milliseconds, 1,000 times faster than what you see on mainnet. Now, what you will see on mainnet eventually, when all of the pieces are in place, and it's not going to happen with this one change, but when all the pieces are in place on mainnet, we're going to see those consensus latencies come down literally to how long it takes to propagate information. So the first HIP that we talked about today, the broadcasts, that helps because it just makes sure that we are disseminating the events literally as fast as those network cables are going to send the events from member to member. And then the second part is that by doing multiple other parents, we have to send fewer events to produce a round. So we should see the overall consensus times drop dramatically once all the different pieces are in place. But that's why multiple other parents helps, is because it reduces the number of events you need per round.
That was great and really clear. Thank you.
Thanks.
Yeah, thank you, Richard. Appreciate it.
Yeah, well, with that context, I'm happy to help.
Okay, cool. Anybody who's not happy to vote now? Okay, perfect. Thank you. So let's do a vote on HIP 4046. Let me start with you, Michael.
I vote yes. And Richard, thanks for the presentation.
You're welcome.
Thank you. And Stoyan.
I vote yes.
Georgie.
I vote yes.
Megan.
Yes for me.
Richard.
Yes.
And I vote yes too. Great. Thank you all. So HIP is approved. And thanks, Michael, for moving that forward. That's great. And yeah, thanks, Richard, for sharing those insights on the consensus mechanism. Cool. Okay, so let me share my screen again. So before we come to another topic, Mark, anything else regarding HIPs? Like, do you already know that we will have an upcoming HIP next week, or anything like that that people should have a look at?
No,
Okay.
new hips coming next week.
Oh,
Thank
okay.
you.
Perfect. Thank you. Um, so with that, I have two more topics on the agenda today. Both are related more or less with AI and with AI-based contribution. Um, oh, I'm not sharing. Whoops. I want to share. What is it? This one. AI contribution. And I believe many of you are aware of the problem of AI slop that with all those great tools like Claude Code, Copilot, ChatGPT, Cursor, and so on, where people now have tools which makes coding, yeah, some say more easy, others say different. Um, those a lot of people now start and try to contribute to projects from time to time without having the deep knowledge of those projects. And with getting all those new contributors to Hiero and working on good first issues and being part of the LFX mentorship program, what we have seen in the past is that the Hiero project is getting a lot of AI slop too. And I was pinged by a lot of maintainers and contributors how to take care of that, how to handle that, how to behave in a situation where it's clear that a PR is not acceptable at all because it's clear that this is generated by AI. Maybe the same person just created the issue 5 minutes earlier and comes up with a large pull request. We've seen all that. And to help the maintainers of Hiero, we created some maintainer guidelines. And this is a pull request at the moment. And my ask for everybody, especially for the maintainers and committers of Hiero projects, is to have a look at this pull request and give feedback if that is helpful, if that hits the tone you would like to have when talking with contributors and so on. Because what this guideline does, it defines what programs we have, like why is this guideline exists, and it gives, what are possible red flags regarding, oh, here's a pull request that maybe don't make sense, maybe is created by AI slop. And then we have created a kind of escalation ladder from, yeah, we super helpful and try to help those people to get their stuff in, up to, so sorry, we need to hard stop this PR because yeah, we cannot invest more time on it. And for all of those steps, there are even ready to use response templates where that if you would like, you could copy or in a better way, copy it and rephrase it so that it fits to the real use case, but will give a good answer to whoever is working on it, and it gives some ideas what you can do in the repository to get rid of some of those AI slop. And at the end, it even gives an idea about some very specific situations that we have seen, how you can take care of that, including things like Hacktoberfest, where we assume, at least this year, it will be crazy regarding the pull requests and so on that will be created in October. If not, GitHub is changing some more things here. So if you are a maintainer, please have a look at that. Happy to hear feedback from TSC members too. While it's not technical, I believe it will be an important part for the maintainers, for their handbook to show how it works. And I already shared this with LFDT, so Jessica brought it to Hart and others from LFDT. And maybe in future we will have something like that, not on the higher level, but maybe even on the LFDT level. But since we now really facing those problems, and I got a lot of requests from people, I think this is a good start to have it here and then move it up the ladder to LFDT as a next step. Any questions or comments on that guideline? Good. Okay. Which brings me to the next topic. And here we go the other way around. Here I will present something where LFDT is currently working on for all the projects within the LFDT, which are AI guidelines that give an overview about how AI should be used when creating code or any other artifacts or resources within projects under the LFDT umbrella. It's not final. Again, this is a pull request too, and it's currently discussed by the tech. But I believe it is good to already share it with the project within LFDT and get their feedback, because that is a guideline for the people working in the project, right? And from my point of view, that is very important to get those informations into the tech before decide anything. So before we maybe discuss about it, let me give you a short overview about what it is. So it starts with some general guidelines. I think the most important one is that whoever submits code is accountable for that, which means if you use AI, you cannot say like, oh, the AI did it, I'm not accountable for it. It's like you do the pull request and you are accountable for it. It gives some ideas how Turing from the AI space that is used to achieve a commit can be added to the commit to give information about that. And everything else is really more about legal stuff, about what AI cannot do. Like AI cannot do a DCO sign off, so that is still what you as a person need to do, which means like even if you use AI in your workflow as a tool for creating code or whatever you commit to an LFDT project, you are the developer who've created it and you sign the DCO and not the AI code. I think that is very interesting here, and then we have a lot of links. I already discussed with some here in the call where I know there are controversial thoughts, especially on 2.2, I think, and that's my point too. I think everybody else next to that is quite clear, right? So I think we don't need to discuss that I could sign the DCO. I think it's clear that contributors should be accountable for what they put in. I had controversial discussions with you about this 2.2 disclosure point, which says that if you use AI to similar to the sign off message that you add with the DCO into a commit. You should add an assisted by message to the commit message that says, hey, I have created the content of this commit assisted by agent X, which used LLM Y, kind of that. And the big question is, do we as Hiero want that? Do we see a benefit there? Is that just, additional stuff nobody needs? I see two hands up, and Michael was first.
I guess the first thing that comes to mind is that it would be virtually impossible to enforce something
Yes,
like this.
I know. That's my point.
So I think on that level, it's a bit like, hey, this is really interesting from like an ethical perspective. I have no idea how you're gonna actually get people to do it. And then the second kind of like broader ethical issue too is if you start tagging these things, you're also basically giving free training data to the big AI labs. So now they can differentiate between which commits are human versus which commits are made by the artificial intelligence. I'm not 100% sure that every company and organization would like to do that. I think there's a big group of people who would actually like to get compensated if they're offering that kind of training data. So in broad strokes, whether I feel it makes sense or not, I think the biggest issue for me is really you can't really enforce it.
Yeah.
So what's the point?
Yeah, I totally agree on that point. Richard.
Yeah, I strongly dislike 2.2. I think that it completely undermines the point of 2.1 and 2.3 and 2.4 and the others, which is that you, the engineer, are the one who produced this code. We have never cared. I've been using AI generation long before LLMs, right? Copilot used to do stuff. We never cared. It wasn't we don't care what tool that a developer uses to produce the code. What we care is that the developer owns the code. And I felt like 2.2, like in what way does 2.2 actually help? It doesn't help in terms of ownership because it's the individual responsibility in 2.1, and it's a human review in 2.3, and understanding your own code in 2.4 and so forth. So it doesn't help in that sense. It's also going to create a weird social dynamic where people will I don't know. Like for example, you could look at it and say, "Oh, this was AI produced code, so I'm not even going to review it." I only care if people put care and time into it. So anybody who's got that goes to the bottom of my pile. And if that's the case, then people just won't put it on. And just like you said, Michael, like people aren't going to do that. I think one of two things would happen if we enforce this rule. I would go into my AI free rule set, and I will just say, always put assisted by on whether or not it assisted me at all. I don't even care. Just put it in there because I'm not manually adding this thing every time, right? Just not doing it. And in other words, it's useless. Or somebody will do the other side and they'll just say, I'm never putting that in because this is my work and I want to get credit for it. I don't want somebody to look at some code that I submitted just because I used AI to help me with part of it or to take some of the grunt work away. Like it's my code. I did the work. I reviewed it. I told it what to do. And because of that, I now have to put this assisted by on there, and it's going to look to all the world as if I just typed in some little prompt and then the AI did all the real work. I don't want to do that. That takes away from me and my contributions. So, yeah, I hate 2.2. I think it should be
Diane. And I raised my hand
so-
too. I
Yeah.
agree after
So-
Diane.
So, Richard, your reaction is pretty much completely in line with what I've heard from a lot of other people. And my big issue with this and is that if you can't measure it, you can't. The assisted by doesn't really help us. As it's embedded in the description of a commit message anyways. And so pulling it out and teasing it out is going to be a bunch of work. And if it's not accurate, then that's another whole layer to that conversation. The other thing that I've heard is that people will gamify the assisted by in order to get their tooling a better optics or whatever, however you want to say. So OpenAI will add something in that automatically puts in the assisted by commit message for you or something like that. And then they'll say, we are the most widely used tool for assisting code. So I've heard a lot of these objections. I think the aim of a lot of this, and this is why we're bringing it to you today, is because we're still evolving this at the TAC level. This is the approach that the Linux kernel used. And they vetted and they agreed to as a community. It's similar to something that the Kubernetes and CNCF created, though they took out the naming of the tool. But the the problem I think we're seeking to solve is partially the AI slop problem, and being able to identify when we're getting hit by a lot of slop. So I'm not sure this solves that, but I also know that I haven't figured out a way really to report on it, even if we've gotten it done by everybody. So I'll lower my hand and I'll let Hendrik continue.
Yeah. So my thoughts on it. So before I had a discussion with Richard, and I had a longer discussion with Richard about that. I was like, yeah, I'm coming from this, like SBOM stuffs and things like that, and I was like, yeah, that's additional metadata, and this is getting more and more important to understand where things are coming from and so on, and I'm fine with that, but I do not strongly care, kind of thing. And after talking with Richard, I had a lot of thoughts about it. And the longer I thought about it, the more I dislike it. I mean, the main point is you cannot check if it's correct or not, right? So it's just something written there, and you have no idea has that person really used AI. Maybe there was no real use case to put it in if you didn't use it, but you can create it's full code with AI without putting assisted by into it. That is, I think, one problem. And the other point I was thinking about is, so when it comes to AI, what does it mean? It could mean you wrote 3 lines of text and the AI created that full pull request. It could mean you worked days doing research with AI to come up with a solution that fixes the problem, or it could mean you had auto completion in your editor, right? Which I use since I don't know how long. So the question is, what does really assisted by mean? Is it like auto completion already is assisted by? Where does it start? Where does it stop? And I think with that, there are so many open questions, and I agree on this point that maybe just doing this now is not what we want. We want some kind of answers maybe on some questions, but I think this is not the thing that will help us in those topics. Diane.
I think the key thing for me is that an AI agent can't do the DCO, that it has to be a human, so that someone can't give permission to an AI agent to do a DCO, and that as if I'm not sure how we totally measure that still and how we identify that, but that for me is the piece of this puzzle that's the most interesting, so that we continue to have human review and human accountability for the code that gets embedded into our systems. And so rather than the disclosure, as long as everybody agrees to that other section, if you roll down about the DCO, the that's the stronger part for me in terms of what we're going for at the TAC level, and that it is really human involvement. I don't care so much which tool, and I really care that if we're going to do this disclosure, we have a really easy LFX insights way of measuring it, and we don't have that at this point. So those are the two things that I'm keen on resolving at the TAC level.
Michael?
Maybe it's a total side quest. I dropped a comment too, but I know, Hendrik, I told you about this idea a while back. Um, Theoretically, it's actually a really good use case for the Hiro ledger. If you've got maintainers or contributors, they could sign a message on HCS attesting to the code or attesting to a version of a package and so forth. And because of the low cost of running a Hiro ledger, I think this actually could be a really, really good use case. I think it's really possible to abstract most of the wheels, so someone doesn't have to deal with wallets, PKs, or anything like that. You could use a phone or mobile app to actually do it. It's kind of similar to like the Authenticator app experience. Or alternatively, you can even just use an Authenticator app as like a 2FA for signing those commits. Take it one step further than Dash S, because realistically, signing a commit is very, very easy to automate with AI today, and there's no way to verify that at all. Uh, so I don't know that just using Dash S is a solution to this problem. I think the scale and scope of AI today is only going to get worse, and we need solutions that kind of take it to that next level so that you need that human intervention.
Yeah, totally agree. So Keith, and then I raise my hand too. Keith, you're muted, Keith?
Yeah.
Yeah.
So I just had a quick question on this policy. I mean, what we're really trying to prevent is abuse. So if we have someone who's just completely abusing and submitting lots of bad PRs, sorry, I've not read through this whole policy. What is our stance on banning people or and the technical capability to ban people from submitting any future PRs?
Yeah, you can do that, and LF already did that. I don't know if it's like just for a given period of time or for forever. I mean, and I know you can as an GitHub org owner now even do, some configurations that some accounts are not allowed to do more than X over a given time. But I'm not deep into that because this is the GitHub maintenance. Maybe Jessica can say more about that or at least figure it out. But yeah. So we really had those cases. I even tried to contact somebody who created pull requests like crazy. I found him on GitHub and I contacted him on GitHub and tried to talk with him and tried to teach him that this is not the way. But sadly, that failed. So I know this account has been, I don't know, like deactivated for doing PRs at some Hyrule repos at least. Jessica?
Yes, I was looking into those guidelines. I want to call them. I don't know how to call them, but yeah, it's a setting that can be done at the organization level and repository level. I need to look a little bit more on them, but I was just briefly playing with them last week, and while it is a way of protecting us, it's still a little bit. It's still a little bit of a chore to maintain them long run. So, I mean, it could definitely be something that we can leverage meanwhile other methods come in.
Cool. Thank you. As said, I raised my hand too. So, Michael, I totally agree on it. Like, even before AI, I often said, I do not get this dash S and how you can, by a command line flag of the Git to do something like sign a contract. And even 5 years ago, I was like, I don't know how many people just do this and have no idea what they are just doing. And I totally agree that this can be done so easy with AI. So that's why I say this is not the solution. Something else will be the solution, but I don't know how that will look like. Yeah. Yeah. And block first contribution, that's a problem too. But I think we're good on that one. Okay, we're at the end of the hour. Thanks for the discussion. Looks like we agree somehow that the assisted by don't looks like the best idea for now, and Diane and I will bring that to the tech. Cool, and see you all in any of the upcoming meetings then.
Thank
Bye.
you.